Thanks so much for hosting us, Fonzie and Mindspace. Really cool space here. So I'm here today to talk about observability for AI agents. This is something that speaks to me very deeply, not just because I work in an observability company, but because I think in order to build systems that actually work, you need to be able to observe them, you need to be able to improve them. So, like the slide said, I'm the VP of Engineering at Arthur. I lead all of our engineers from research and development through implementation. That's everything full service. Prior to that, I was at Palantir for about 10 years, did a lot of different things at Palantir, forward deployed engineering, reliability engineering, software engineering, managing teams, solving some extremely complicated engineering problems, very complicated software in very complicated environments. You can think of tents in the desert in Afghanistan. And also I was an instructor at Rutgers University. I taught big data and machine learning. It was a continuing education program, and it was really about how you use data to do storytelling. So I've been working in the AI data space for quite a while. So for today's agenda, we're going to talk a little bit about an introduction to AI observability. You might have heard the term evals or evaluation sets or whatever. So this is going to focus on generative AI instead of the sort of traditional AI. We'll go over a brief history of what that looks like. We'll talk a little bit about the current state of the world. And then I want to end with a call to action for everybody who's building with AI and thinking about building applications or integrating it into your workflows. Sort of what steps you can take to ensure that you are building really high quality applications and user experiences. So, a couple recent news articles over the last couple of months have come out. I think vibe coding is super cool. It's certainly helped me in my day-to-day, but I think if you're just vibe coding and pushing things into production, obviously you're going to have some problems here. As experienced, I think Supabase had an MCP server that leaked database, entire contents of a database. Replit had an agent for some customer that basically destroyed their production database and then lied about it. Pretty interesting. MIT also, this was a pretty bombshell report dropped about a month ago, maybe a little bit more. 95% of generative AI pilots at companies are failing. I think there are a couple of really interesting learnings from this report. I think one that speaks to me is actually the definition of success at most companies when they're evaluating an AI initiative or project is they're just looking to see if people are using it. They're not even looking at ROI, they're not looking at value add. It's just hey, people are using this, that's great, let's roll it out. So I think obviously lots of room for improvement here. I think that's why we're all here tonight. There's a lot of really cool things that we can do with this, we see potential, but what does it actually take to move beyond those vibes and get into production and solving real problems? So this is a thing that we've kind of come up with. This is more, kind of content speaking to maybe a larger enterprise, bigger businesses. But I think a lot of the message here is true for anybody really thinking about AI. And this is really everybody is asking, how can we trust that if we're going to be rolling out AI, that it actually works, right? So I'm not going to read every 10 of these questions. I think, these all are going to speak to people in different ways, in different contexts. They're working on different projects. But the goal here is you want to be able to answer yes, especially if you're deploying into a big enterprise, a highly regulated space, a very complicated project. What's interesting about AI observability, it's a little bit different than sort of just traditional application monitoring or observability is, your metrics, your data in traditional observability is very safe to log. You can think of service names, IP addresses, latencies, I think it's not very sensitive. But these AI systems that are actively being built and deployed operate on, in many ways, the crown jewels of the data that customers are using that AI system for. So you can think of things, like PHI, PII, PCI, right? These are all solving really hard problems, but it's really sensitive data. And so if you're going to expose your data to an application, you need to be able to trust that it's working correctly before you even get to the point of evaluating, is this thing going to be providing value? So a brief history here, we can sort of talk about what our approach to observability looked like since early 2023, end of 2022, early 2023. Arthur, one of our claim to fame is we had the first LLM firewall product that we brought to market for the enterprises. It was called Arthur Shield at the time. Now it's part of our platform. The general idea here was that, in order to set up observability or monitoring for your generative AI applications, you basically, within an application you're building, you jam it right into business logic. You put it directly in the code that is inferencing the language model. And so this was a good first attempt, but it really sucks because especially if you're a developer, you understand this, like, it's a lot of work to maintain this. You basically have a surface area of everywhere that you're making a call to a language model. You have to inference, and then you have to monitor that inference. It also really sucks because it takes a pretty hard dependency on the language model provider. So if you ever wanted to switch from OpenAI to Anthropic to DeepSeek, whatever different API format you're using, you have to go in and update all of the code. So I think this was an approach that lived for a very short period of time. And then the tooling got a little more sophisticated, right? So this is an example pulled from like the Vercel AI SDK integration that we have, but the idea here is that there's some kind of library support for doing this observability. So you can take a middleware approach where you're basically wrapping the observability in the call that's doing the inferencing. Some other libraries do things like callback hooks or like event hooks, or you can monkey patch the library. This is a very common approach in the Python language. This is easier than the first version, but still requires some work, right? So this is tied to a very specific API. So, if you're using Vercel AI SDK and you want to switch off Vercel AI SDK, you're kind of screwed, right? It's going to take a lot of effort to move to a new framework. And then similarly, this only supports like synchronous checks, like in-band checks, right? It doesn't really support asynchronous or batch workflows. You can certainly build middleware or whatever to send these events to sort of a source, but then you have to orchestrate and build an event pipeline and all of that stuff, and that is challenging to do for those of us who have done it. Similarly, like this only supports sort of like user-sent language model calls. It doesn't capture like intermediate turns to the language model. So if you do things like tool calls or RAG retrievals or whatever, these approaches usually don't address getting that information, which is extremely relevant because the context that goes into an inference obviously is like hugely important to understand what actually happened with that inference. So where the industry is moving today is standardizing over a telemetry standard called OpenTelemetry. This was an initiative, I believe, that came out of Datadog, which is great. I love the approach to open standards. Open standards are great for a lot of different reasons. What's great about OTel here is that a lot of customers, a lot of the industry is already using OpenTelemetry. It's a very flexible architecture. So you can support things like going into a big enterprise where they've already got an OpenTelemetry stack stood up, or you can go into a smaller startup or mid-market companies that might not have that set up, but you can still use the same protocol. OpenTelemetry is an open standard, so you don't get vendor lock-in, right? You can swap different vendors, you can swap different providers as long as you're implementing that standard. It's going to work. And that means that like the ecosystem around you is pluggable, right? You can participate and play well in the sandbox. If you're a vendor building an AI tool that's orchestrating or implementing OpenTelemetry, you can plug into observability tools, you can plug into any other tools that might be hooked up to callbacks on the OpenTelemetry bus, data processing, whatever it is, right? Similarly, it supports synchronous and asynchronous batch use cases, and it can capture the entire tree, the turn tree, right? So you can think of this as like a span or a trace. It captures all of this. So really, this allows you to solve sort of what I see as two fundamental problems in AI development. The first is reproducibility. You can take the same inference with the same system, with the same tools, run the same input 100 times and get 100 different answers. So for the software engineers who are building with AI, that fundamentally breaks software engineering, where your first step to solve a problem is to reproduce it. And similarly, it's never the point in these agentic systems where you can look at this very complicated web and what's being emitted and point the finger at, oh, that's the thing that broke. Right? It's a small errors that accumulate as they move through the system that leads to a very large error. So, ultimately, it's impossible to improve what you're not measuring, and you need large sample sizes to do error analysis. So it's kind of crazy to me to think that like we have so much AI application development happening here where we're not capturing or observing or implementing observability. I don't know how you can ensure that your system is working without it, right? I think this is very complicated. So, OpenTelemetry right now, the biggest fallback or sort of like where the work is, it currently is aligning on a semantic structure. So a lot of the vendors who are implementing observability features all kind of have their own sort of like what the payload looks like when it goes into OpenTelemetry. I'm going to highlight here the OpenTelemetry Gen AI committee. They're actually starting to think about this and push this out, and I think this is the standard that's going to emerge. So definitely something to pay attention to. But again, right, the reason we're doing this is customers are getting locked into single implementations, making it hard to switch, limiting your ability to add functionality. Your app just doesn't play well in the sandbox. And developers, on the flip side, have to build app-specific scaffolding. It's hard to maintain, difficult to make changes, etc. So my call to action here, right, is I think every AI application should have observability built into it. I think the observability it should be using is the OpenTelemetry GenAI standard. So if you are building AI, if you are working with AI, if you are involved in AI, you should be building, you should be questioning, you should be pushing for observability, because I don't know how you build trust in a system without being able to observe that system. And so, and I think the advantage here for those of us who are building AI is this cross-stack adoption can lead to big opportunities for your business. You can lean into partnership sales. You can open new distribution channels. You have a stronger value thesis, not just in, hey, you can trust that our application is working, but if you bring us on, we integrate into whatever observability tool you're using. You might be using Arthur, plug, or you might be using some other observability tool out there, but you know that if you deploy our software, it's going to work, and this is how you're going to see it work. So.
Okay, hey everybody, my name is Jonathan. Most people call me JLo, and I am a prompt engineer manager at the browser company. I started at the browser company about 2 years ago, and I first started in a strategy and operations role, and then I became our first prompt engineer about a year ago. And so, for those of you that don't know, the browser company builds a browser. It's called Dia, and it's an AI browser that lets you chat with your tabs and brings in context from your browser to integrate with your AI workflows throughout the day. So today, what I'm going to talk about is why you should build a team of prompt engineers and why you shouldn't call them prompt engineers at all. But before we get into any of that, I want to sort of take a step back and look at some screenshots from the early web. And so this is a screenshot of eBay.com in 1996. And I think one thing that sort of stands out is it's a very minimal design to today's standards. And I think the reason for that is because in the early web, the main thing that software engineers were focused on, as Zach eloquently said, is to just get the shit to work. But as the early 2000s progressed, you saw a major shift in web design. And it became really evident that it was extremely important to companies, to engineers, and to a product that design was front and center. But if you think about the early days, software engineers were basically the ones doing web design because they were the ones in the code base and they were closest to the HTML, CSS, etc. And so I think that there is a very similar parallel that we'll see with prompt engineering. And so we're in the very early days of AI products and building AI products. And because of that, software engineers are the ones that are the closest to the prompts. They're working and integrating the LLMs. But prompt engineering is actually very nuanced. And it isn't just about writing really good prompts. There's a lot of different parts of it that we do at the browser company that I think help us move really quickly. And so the point that I want to make is investing in prompt engineering as its own function today will be like investing in product design in 1996. So if we look at the browser company and how we build AI products, I wouldn't focus too much specifically on all the arrows and all the boxes, but the whole point is that we have a very systematic process for how we work on AI features and how we ship product. And each one of these boxes is something that a prompt engineer will focus on. So a prompt engineer is not just writing a prompt, but the end-to-end flow is that they're thinking about a product requirement, they're figuring out what are the potential solutions, they're implementing that solution, one of which might be writing a prompt, they're writing an eval to test what is the expected input and what is the expected output, and does my solution get us there. And then they're constantly iterating until they're ready to ship. You ship, you get feedback, and you sort of work in this continuous loop. But prompt engineers don't just own the prompt writing. And I think that we will start to see this more and more in the next year or so and in the coming years. And the reason for that is prompt engineers sort of like the main term that people use. There's sort of this new discourse around context engineer, which is going around places like Twitter, which is more about, okay, what is all the context that I'm going to feed into the LLM? And so there's sort of this argument that they should be called context engineers. But I think that's only 2 of the 4 main pillars of what prompt engineers do. And really the one that I would key in on the most and that I would focus on when thinking about building AI products and somebody who is writing prompts is the product thinking piece of it. And the reason for that is a lot of what I'm doing in my day-to-day or any of the prompt engineers at our company are doing is they are thinking through the product requirements for a given feature. So in the same way that a product manager is going to an engineer, a designer, various stakeholders, and they're all painting really broad strokes around what a feature should do, it's then up to the prompt engineer to collate all that information, take all that gray space and ambiguity, and really figure out what are the requirements for what we're trying to ship. And then what you do with that is you document that. It could be in something like a more traditional PRD, but oftentimes what it's going to be is in the form of evals, like Zach was talking about earlier. And so you have an eval platform, but what the prompt engineer is actually doing is they are writing in that platform, okay, for this feature, here's an input and here's an output. And in order to do that, you need to really deeply understand exactly what your feature is doing. And then once you have those evals, it makes prompt writing much easier. And so all 4 of these are really nuanced skills that go beyond what most people consider prompt engineering today. And so at the browser company, we are building a horizontal functional team of prompt engineers. And so we work in, we have different product pods that have engineers and designers. We're also placing prompt engineers on those product pods to work closely as embedded members of the team. Okay, so this entire time I've been talking about prompt engineer, but at the beginning I told you I was going to tell you why you shouldn't call it prompt engineer, and I've been sort of explaining these reasons because I think the term prompt engineer is a bit reductive to what the role actually does. So if we're not going to call it prompt engineer, then what do we call it? And at the browser company, the way that we've decided to build the team is around model behavior. And the reason that we're calling it model behavior is because I think that is the most descriptive way of describing what the role does. You are taking a model and you are teaching it or you're telling it how you want it to behave to achieve your outcome. And so to give a more prescriptive description, the model behavior is a function that defines, evaluates, ships desired behaviors of models, turning principles into product requirements, prompts, and evals that make models useful and reliable. And I would sort of key in on these key terms as what describes somebody working in model behavior. Whoops. And so finally, the main thing that I will leave you with is, if you think back to the original example of the software engineer in 1996, who was basically the first version of a designer because they were the ones closest to the code at the time and they were designing, we saw that there's a major progression and design became its own function that now is entire people's careers, it's entire parts of organizations. And it's because there is a very nuanced craft and a very nuanced skill behind design. It isn't just that you are sort of pushing pixels onto the page, but you're actually figuring out what does the user want, thinking through user experience, human-centered design. And in that same way, I think we will see a similar trend with prompt engineering. And that is why at Browser Company we decided to split this out as its own team and really sort of build it out into its own function. And our company itself, we tried to hold a very high quality bar when it comes to design, a very high craft bar. And we think that this allows us to continue to do that further.
Awesome. So today I'm going to talk a little bit about Graphite and also our experiments within AI Code Review. So before I talk about how we built AI Code Review, and I want to tell you the story of how we experimented and iterated and what we learned around how to get Claude and other LLMs to do code review, I first want to tell you a little bit about Graphite. Some of you might know us and use us. I know the Browser Co. I love working with the Browser Co.'s engineering team. They've been using Graphite for a while. Fundamentally, we help engineering teams ship more code faster, safer, better. We're essentially a client on top of GitHub for helping with the create, review, and merge of pull requests. We're used by, honestly, some of my favorite engineering teams in the industry. I'm so proud. The best part about working on Graphite is like the engineers and the engineering teams we get to Slack and call and work with every single day. So here's a screenshot. It doesn't show up super well here, but fundamentally, again, we're like a website that gives you a client on top of GitHub. It's stealing good ideas from internal tools at Facebook and Google. If you've ever worked on one of these larger companies, you might be familiar with like Fabricator. There are better ways to handle these pull requests, and we try to give you those superpowers in a client that any individual engineer can pick up and start using right away. Now, of course, we wouldn't be a company in 2025 if we weren't also layering on AI features and marketing and branding ourselves as AI native. Fundamentally, I'll be honest, Graphite, we've been around for 5 years. We've been doing cool stuff since before the LLMs were popular and on the scene, but they've been a fantastic disruptor and tailwind in this space, and we've found amazing ways to leverage AI and level those features onto an existing new surface area, this pull request page. One of the ways in this screenshot is we have a AI chat where you can ask questions, ask deep research style queries, look up information from other pull requests, and even modify and resolve comments in line, kind of like cursorifying the PR page. So I want to take a step back and talk about what we've seen, because we see so much is going on as AI is shifting software engineering. And what are we kind of seeing at our level of things? Of course, there's so much going on in the code gen side of it. And the way that we break this up is we think about two loops of software development, the inner loop and the outer loop. Code gen, I'm sure every single person in this audience has been playing around with, Claude Code and Codex and Cursor, these kinds of tools. And I think that's been hugely disruptive and powerful and innovative on the inner loop of software development, the creating that code change on your local machine, testing it, running your unit tests locally, and then pushing up a PR. Now this is creating a big problem. It's creating a new bottleneck. I think there's also probably senior software developers in the room who have had the headache of seeing engineers submitting them 10 times the number of PRs than before. Maybe a junior engineer stays up all night, submits like 10 PRs, and now you are tasked with reviewing and dealing with these code changes. Not only reviewing them, but testing them and then carefully merging them out to production. That's the outer loop of software development. There's so much that goes on in our jobs to actually getting a code change out the door. This is what I'm kind of obsessed with and what we're obsessed with within Graphite. How do we help that outer loop? How do we help people validate, review, and integrate those software changes faster and in a safe way? So, and the numbers are actually really clear. Like you look at, we talked to the Facebook engineering team, I think they've already seen like a 2x increase in PRs per engineer this year, and they are estimating it'll double again. This is like a real problem. I think the Anthropic founder was tweeting that their merging and merge queue system is immediately becoming the bottleneck within Anthropic's engineering. So we do a lot of things at Graphite to assist this stacking merge queues, but I want to tell you, it's an AI talk, so I want to tell you about our journey in helping pioneer AI code review. This is something I've been obsessed with for a while. This is my co-founder, a screenshot from my co-founder, Tomas. Him and I have been obsessed with this for a while. Ever since ChatGPT, I've been taking diffs from GitHub, just the raw diff, and I've been posting it into chatbots, and I've been like, hey, review this for me. And at every model generation, I've been so curious, like, is it smart enough to actually give me a useful review? And you have ChatGPT 3, 3.5, these new versions will come out. It's very exciting. I'm getting like cooking recipes at home, and I'm like, okay, but can I use this at work? Can I like feed in a diff? And the reality is, for the longest time, it kind of sucked. I don't know if you guys ever tried this, but you'd feed in a diff, and it would write you like a nice essay about like, oh, here's like a code review. It's like kind of it's kind of correct, but it's not useful. Now I have to read the code. I have to read this weird essay it just printed out for me. That's not what a real code review is. That's not like actually helping me create actionable changes in these PRs. And the dream here, this is a screenshot of where we're at. There's some other tools. We're not the only people in the world who do AI code review, but the dream is like really nice, inline, actionable comments that are calling out something specific that I can fix on the spot. I don't want to deal with small little subjective nits. I want real deal bugs and issues. And otherwise, I actually don't want to hear about it. I don't want to have to read a single line more than I have to already in code review. So either let me know if there's an issue or be very quiet. That's hard to get an LM to do, but that's the dream. So initially, that's not what we had. Initially, if you feed it in, you get a class of concerns that you don't really care about. In fact, specifically, it's a class of concerns that's kind of wrong. It's a lot of like it claiming you can change the code to be what it already does. It's actually getting factual mistakes on some niche CSS stuff. It's not very helpful. And now you lose trust as a developer in this code review. Part of this is a model intelligence problem. So one way you can slice this problem space is you can say, okay, hey, there's some stuff that LLMs can reasonably catch, and there's probably some stuff that they can't catch, that we shouldn't even try to catch. This is an important finding. I mean, on one level, it means that we still have a job. We're still safe. There's still value, and this is something I deeply believe. Humans really, really, really should stay involved in code review for the time being. Even if we have and continue to get great AI code review systems, we should treat them like unit tests and like linters, and the humans should still stay in the loop because there exists today and will continue to exist a lot of bugs and issues that only humans can detect. But there's some stuff that LLMs can detect. Just like unit tests, just like linters, there's some stuff you can automate here. Now, what I realized very quickly as we were experimenting with this is that there's also another class of issues here, which is stuff that's like technically correct, but I really don't care about. This is like the annoying teammate engineer who's just badgering you with nits over and over again. And you're like starting to get frustrated. You're actually like giving them like polite feedback, like, yo, can you like please stop giving me this kind of feedback? You're like technically you're right, but we don't do that here, or that's not our preference, that's not how I code. And so what we realized is that there's also a genre of comments that you just want to receive, and there's a genre of comments you don't want to receive, even if they're technically correct. So now we start having this like matrix of comments that you could possibly create on a PR with AI code review. And as we've gone through this process, and I think at this point we've scanned tens of millions of PRs in production, we've gathered all these comments, and then we've also done meta-analysis, classical data science, and then also using meta LLMs to kind of categorize the types of comments we're leaving. We're able to kind of see, okay, there's the class, the top right here is kind of classic comments that are actually pretty useful. Bugs, security, performance issues, sometimes style and documentation, though it starts getting on that edge of subjectivity. It depends what your style guide actually is. And then there's a whole classes of things that we really don't want to comment on review. The nice thing is, as these LLMs keep getting smarter, and every week I get to go to Hacker News and see that a new LLM has dropped, the top right quadrant is expanding. It's kind of nice. It's expanding, one, because the models are getting more intelligent, and two, because those context windows are getting a lot bigger. When I was playing with this, I used to struggle because there was like, I could only fit 100 or 200 lines of code into a ChatGPT 3 or 3.5 query, and so I couldn't even get a lot of context. And now, as we all know, they're like a million token context windows. You can feed in a ton of context, the code change, other relevant files and issues, and you can even get agentic for loops going. So we're growing that up top right quadrant here, what's useful as the intelligence and the context gets bigger. To date, this is where we're at. This is in production as we've left, and again, I think it's in the tens of millions of code reviews at this point. These are the kinds of things we're catching in production. Bugs, style, sometimes security. Security is like such a critical one. Like 1 or 2 good security comments saves the entire world. But there's a question here that we grapple with, and it's cool hearing the other speakers, think a lot about like observability and correctness. Like, how do we know if these reviews at scale are useful? Of course, we can review the reviewer. We can, who watches the Watchmen. But at a scale, you kind of need to think more systematically about if we're doing a good job or not. And we think about evals, we think about hill climbing. So one way that we can measure this, upvotes and downvotes, great. We can put that in our UI in a comment. It's rarely clicked, but when it's clicked, especially downvotes, it's a real issue. And what we find in production right now is about 4% of the comments we leave are downvoted. So that's a signal, that's nifty. And honestly, I think most of the downvotes immediately get posted into like a team Slack channel that we can then review, audit, consider adding to our evals. But what we found to be more useful in the case of code reviews are determining if a comment actually had action taken on it. And the way that we discern whether or not action was taken on it was whether or not that line of code was updated before that PR was merged in. This is a proxy. This is not like a perfect metric. But you can say, okay, hey, fundamentally, if you comment on a specific line of code and that comment is trying to call out a bug or something, and then someone goes and updates that line of code before merging it in, we can have a reasonable proxy metric that led to an update taking place. And what's better is we can also compare this to all the human comments that are being left in the world. Human comments, they don't have upvote or downvote rates, but they do have actionability rates. And so what we see when we do our data science, we see human comments about 50% of the time, it's a nice clean number, actually result in that line of code being updated. I always wonder about the other 50% of the time, if that's just people ignoring their annoying knitting teammate. But what's nice is we can goal and we can successfully get the LLM to leave comments that are hopefully more actionable and resulting in more action than just human comments. It's like self-driving cars. I need the bar of usefulness and trustworthiness and annoyance to be not just as good as a human. I need this to be better than a human because people love to hate on AI, they love to hate on robots. And the moment that you start posting annoying, incorrect, false positive comments in a code review, you lose the developer's trust. Even at our best, we still make mistakes, and all these systems makes mistakes, but we really need to not just be as good as a human, but actually better than a human in the actionability and the correctness of this stuff. So this is what we've been doing. This is how we've been kind of iterating through our journey on AI code review. It's in practice, and I don't have slides for this, but talk a little bit about the engineering behind this. It started as a simple system, as I said, of just let's take that diff, let's feed it into probably usually like an Anthropic Sonnet query, Sonnet 3.5, then 3.7, then 4. And we've gotten more sophisticated. Now we'll also take into consideration style guides from the users, custom rules, and we'll use that to source bug ideas. And then we take it a step further and we say, okay, great, maybe we've come up with 1 or 5 possible comments we could leave on this PR. And then we'll run it through a pipeline of critics. We'll actually try to find all the different ways we can veto and invalidate these comments. I talk about the trustworthiness. One of the best ways to get good, trustworthy comments is to say, okay, there's actually about 20 or 30 classes of comments that LLMs are reliably incorrect on. And we can use secondary LLM queries to find those cases and just immediately throw away the comment. Because I'd actually rather not leave a bad comment than catching the positive comment. I really just want to optimize down that false positive rate. So we self-critic down. And then we can run through formatting pipelines, and we can run agentic style queries and deterministic style queries. We can do all this stuff. So this has evolved into a pipeline. The cutting edge, I don't know if you guys are following, but just this week, OpenAI is starting to practice with Codex full sandbox reviews, where they'll spin up a sandbox in the cloud, clone the code, and run Codex agent in that, that 10-minute infinite token for loop to try and find bug ideas. So we're also starting to leverage this pattern too, where we're doing the same thing, and we're able to run the CLIs of Claude Code and Codex and so on to come up again with these bug ideas, but then put it through our pipeline of filtering out the false positives, ensuring consistent style, making sure it's actionable, and then leaving it on the code review. So this is, as I said, this is roughly the state of the art of AI code review. I think it's going to keep getting better, but this is what we're hacking on pretty aggressively at Graphite, amongst many other things. Thank you so much for listening.